Alright, so let's take a look at this problem. First thing we want to do is we want to get the cube root by itself. We want everything that's not in that cube root over the other side. So the first thing we do is subtract 1 from both sides. Subtract 1 from both sides. We have the cube root of 3x plus 5 is equal to 2. Alright, so the next thing is we've got to get rid of that cube root. So the opposite of a square, oops, that's not the button I wanted to push. Just go ahead and just get rid of all that. The opposite of a square is to square it, and so you get x. And so the same thing here, if we have a cube, the opposite of that is to cube it, and you would get x again with this. So the opposite of a cube root is just to raise it to the third power. Yeah, no, that's not what I wanted to write there. So we're going to cube both of these. Cool. So we're going to bring both of them up to the third power. I'm pretty sure that 3 over there is supposed to be on the right side, but yeah. Oh well. We got 3x plus 5, so now the cube root's gone. We don't mess around with anything on the inside, leave all the gooey stuff alone. We just bring 2 to the third power, so 2 times 2 is 4, times 2 is 8. We have now just a very, very basic math problem. Subtract 5, 3x. 3x is equal to 3, and then the last step here is to divide both sides by 3, and you get x is equal to 1. And then the proper math thing to do is to then go throw the 1 back in there and to check and make sure that works. It's a cube root. Honestly, I don't really care right now because there's very few scenarios of where that's not going to work. If that was a square root, that would definitely need to be checked. We want to make sure that we're not creating a negative on the inside of that because we can't take a square root of a negative. But it's a cube root. We can do a lot of weird stuff with cube roots. So we're good. The x works. Just, don't snitch on me that I don't check. So, all right. Let me know if you need anything else.